G'day everyone, welcome to another webinar. This time about the amazing designs in all living creatures. Now before I go into it, I'll just let you know that we are going to answer questions as they come in on the right side of your screen here, and I and one or more of my colleagues will be able to help answer them, but just a small request that the questions are dealing with the topic of my talk, because we have a great website, as I'll explain, where you can find answers for all sorts of different topics with 12,000 articles on the site. But a bit about where I'm coming from. I am a PhD scientist. I mean, there are plenty of people who say that there aren't any real scientists who believe the Bible, but there are actually plenty of us. And in fact, one place you can find them is our book called Busting Myths, which has interviews with 30 PhD scientists who are physicists, chemists, paleontologists, rocket scientists, even the inventor of MRI, all interviewed in this. And in fact, science grew out of a Christian worldview. The idea that we have a divine lawmaker who's a God of order, not the author of confusion. So science actually grew up in a Christian framework of the Middle Ages in Europe, where it was stillborn in places like ancient Greece and ancient China that lacked this idea of a divine lawmaker. And I guess by now, you know, I'm not from this country, even though I became a citizen of this country last year. I originally come from this country, and I did move over here about 10 years ago. And one reason is we have two granddaughters who live in Florida. So instead of flying 9,000 miles, we only have to drive 500 miles to visit them. I'm also a retired chess master, something I used to do for a hobby, play blindfold, which is from memory. See, I'm playing here on the left side here, and I'm playing these 12 guys. This guy's making my moves for me and telling me what they're doing. And played some good people in my time. Another thing about me, I'm also ethnically Jewish. My name is the Hebrew word for Frenchman, which means I can tell Jewish jokes and French jokes and get away with it. But one thing to know, we have this website, as I mentioned before, where you can find all sorts of great stuff. And just in case you don't remember it, our website is creation.com. And one place you can get informed about what we have on our website, as well as creation speakers in your area. Once this illness pandemic has subsided, you can go to our free email newsletter. And in fact, this comes out every few days. We promise not to spam you or to give or sell your address to any third party. And in fact, you can sign up as we are going right now. Text your email and zip code to this number. And the site answers two basic questions. Is creation true, and does it matter? And we can see we have all sorts of classic articles in the archive, and it's updated every day with something new. Like we had an article on the coronaviruses and why God would create viruses. In fact, most viruses are good for us. But when it comes to design, one person to go to is the famous atheist from Oxford University, Richard Dawkins. Now, it's interesting, he admits here, biology is the study of complicated things that give the appearance of having been designed for a purpose. Now, Richard Dawkins, as an atheist, rejects the idea of a divine designer. He thinks that we all are rearranged pond scum and we got here by time and chance and natural selection. But it's interesting, the Apostle Paul also says the invisible things of him from the creation of the world are clearly seen, being understood by the things that are made, even as eternal power and Godhead, so they are without excuse. This must include Darwin and Dawkins. They are without excuse to deny a designer, a creator from what's been made. Okay, so how do we tell whether something's designed? Well, one way is to see it being made, but even if we haven't seen it being made, there are things we can look at. Like take this aeroplane. Now, we know it's designed, but how exactly do you know? Well, one thing you would look for, it has loads of correct components. But you realize it's made up totally of non-flying parts. I mean, the fuselage doesn't fly, the wing doesn't fly, the engine doesn't fly, the cockpit doesn't fly. So how do I ever get back to Australia? Use high-speed rail? No, the answer is they are organized correctly. And every time we see something that's been organized correctly, we know there's an organizer behind it. See, what's the alternative? I'll give you the evolutionary view of forming an aeroplane. See, evolution can be summarized by matter plus time plus energy produces organization. So now I'm going to test this with the production of an aeroplane. So we have matter in the form of a junkyard of aeroplane parts here. We have a tornado to provide the energy, and you can have as much time as you want. And eventually you're going to get an aeroplane. Well, how does this look? Maybe not so believable. Now, what if I told you instead that what I'm showing you here is the aeroplane being hit by the tornado and turning it into a junkyard? Does that sound more believable? Well, do you know why it sounds more believable? Well, the answer is very simple. There are many more ways of being a junkyard than being an aeroplane. So when you have time and energy, you go to the more probable state, which is a junkyard. And you can have as much time as you like, and it's going to still be a junkyard after all this is going on. And this is a very useful principle for all of you out here. I mean, tell me, do you have to tell your children to mess up their rooms? Well, the reason is there are many more ways of being messy than being tidy. So if you have your children who provide energy and the things in their room, it's going to produce a mess because there are many more ways of producing a mess. Simple. So if you want to have a tidy room, the kids are going to have intelligence and know-how to put things in the right place. Now compare this to living creatures. Well, living things are unique because they can make copies of themselves. Your children are sort of copies of you. Now, did you ever see a jet plane having a baby jet? It's not self-copying. And even the factory that built the jet doesn't have baby factories. A photocopier copies documents, it doesn't copy itself, but all living things basically copy themselves. And in fact, your body is composed of about 30 trillion human cells and about 40 trillion bacterial cells and about 400 trillion viruses. I bet you didn't know that, but it's true. And all those cells copy themselves. So we can't even make a machine that can copy itself, but every living thing is a self-copying machine, you might say. So there's no such thing as a simple cell. Every cell has to be enormously complicated to be able to copy itself, as well as to do things like diagnose and repair injuries to itself. Now, I'm going to do a little experiment here. Isn't science supposed to be about experimentation and repetition, observation, testing, all these things? So I'm going to test this idea of matter plus time plus energy produces organization. And this time it's with a frog in a blender. And I turn the switch on, I'm adding energy to the system. And what's the result? Well, it's a frog smoothie. Now, if I left this going for millions of years, you'd think a frog is ever going to hop out of this. Well, again, the reason it's not going to happen is there are many more ways of being a smoothie than being a frog. See what a useful principle this is. Now, another thing is you could actually can this frog smoothie and sterilize it and seal it, and it'll be safe to eat for many years. And not just frog smoothie, it applies to any canned food, canned sardines, canned Georgia peaches. The principle's the same. All the components of life are in the can. But you can apply whatever energy you like to the can. You can have as much time as you want, and I guarantee no living thing will ever form in there. And that's why you're not going to get food poisoning, because food poisoning comes from living creatures. Bacteria make poisons. But the thing is, as long as the can is sealed, no living thing will ever grow in there. And this is actually a real law of science called the law of biogenesis, which says that life comes only from life. It doesn't come from non-living chemicals. In fact, the only way you're going to get bacteria growing in the can is if the seal got broken and it was contaminated from outside, but it's not going to come from within. And this is also why antiseptic surgery works. This was discovered by a creationist called Joseph Lister. See, at one time, surgery was as dangerous as whatever condition it was treating because of the danger of infection. But Lister realized that the things were not being generated spontaneously. They had to have come in from outside to contaminate the wound, so he had an antiseptic spray to stop the germs getting into the wound. And that has saved millions of lives in the last 100+ years. Now, just to give you a little idea of how complex even the simplest living things are, I'm going to go to this famous molecule called ATP. Now, don't worry too much about the chemistry. I'm a chemistry nerd. I'm a chemist by training. You don't have to be. But ATP is the energy currency of life. It's so important that your body makes its own weight in ATP every day and consumes it. So that's why you're not putting on weight. It's consumed as fast as you make it. The point is, cyanide kills you by stopping ATP production. So this is very, very important, this stuff. But now we know it's made by the tiniest motor in the universe.
This animated sequence shows the ATP synthase enzyme in operation. The animation is based on an incredible series of scientific discoveries. Only the colors show artistic license. ATP, or adenosine triphosphate, is the energy currency of the cell. ATP is produced by a tiny molecular rotary motor, rotating at up to 7,000 RPM. These are so small that 100,000 would fit side by side in a millimeter. A current of protons drives the motor, unlike man-made electric motors which use electrons. This portion of the enzyme is where adenosine diphosphate is combined with a phosphate ion in the presence of a catalyst to produce ATP, which is then released, making way for the next cycle. A top view of the enzyme shows the sequential operation. Almost every biochemical process in your body requires ATP. Such a nanomachine exhibits all the characteristics of super-intelligent design. ATP is vital for life, and many of these motors were needed before the first living cell could exist. An evolutionary impossibility.
I mean, think of motors in general. A motor is not going to work until all the components are together in the right position. You have to have something to rotate, something that's held in place, and some power source, as well as coordinating that power source so it's always turning in one direction. So your motor needs all these things working together. So the same applies to these biological motors, which are far tinier than anything we can make. Now, let's go back to the aeroplane again. Just think about yet another interesting issue, and this is the issue of information, the instruction manual. I mean, just think about the aeroplane again. What would really show design here is finding the instruction manual to build it. So not only the components and the organization, but the instructions to build it. And in fact, living things, we also have the instruction manual to build them. And this is the famous DNA molecule, which stands for definitely no accident. Well, it actually stands for deoxyribonucleic acid. Now, this is actually a chemical molecule which has a sequence of letters. In fact, I'll show you a little bit. It has 4 different letters. Yeah, called A, T, and G, and C. And the A always bonds with a T and the G with the C. So it means there's a way not only of having the instruction, but also copying them to the next generation, because A will always go with T, etc. Okay? So in fact, when it comes to your own children, they didn't get their mother's eyes or father's ears. It was the instructions on the DNA for mother's eyes and father's ears that got copied to the child. When fertilization happened, the scientific beginning of life is fertilization or conception. This is not a religious claim, it's a scientific claim. That's when new life begins, and that's where the DNA from mother and father combine to produce the child. DNA, as I say, stands for deoxyribonucleic acid. Now, a bit of chemistry here is that DNA is quite a strong acid. It's a stronger acid than vinegar or lemon juice. And that actually is a good design feature because it means it has a negative charge inside your cell, and that provides an electric force field to protect it against certain attacking molecules that would otherwise break it apart. So that's one design feature of DNA, the fact that it is an acid. Now, how much DNA do you think we have to have? How much information does it store? Well, the simplest known creature that can copy itself is called a mycoplasma. Now, of course, viruses are in the news, but viruses don't really copy themselves. They had to hijack your cell's machinery and use the cell's copying machinery to make more of the viruses. They can't do it by themselves, and they're not really truly self-copying. The simplest self-copying thing is a mycoplasma. Now, this is probably too simple to survive. I think it's degenerative and something more complicated because it can't survive without being a parasite. So this mycoplasma has about 600 kilobytes of information on its DNA, but the information must be incredibly compressed because to try to model what happens when this creature divides in two, makes a copy of itself, it took over 100 computers running for 9 to 10 hours in parallel. So it gives you an idea there must be incredible data compression software even in the so-called simplest living creature. And DNA itself is the densest information storage system in the universe. I mean, you guys have computer hard drives and solid state drives. What are they, about this big? They store 1 or 2 terabytes maybe. But in the cell, a cubic millimeter of DNA would store 1,000 terabytes. So I think you can see that DNA Valley would leave Silicon Valley in the dust. We have nothing to compare with the information technology of all living creatures. Now I'm going to show you a bit about DNA and show you it has multiple levels of information. Now this clip comes from our DVD called Evolution's Achilles Heel. It's very well worth watching. It has study guide as well. Now here we go. See, it's got the sequence of letters. That's the first thing. That's the one dimension. But then you have it's coiled up into certain patterns. That's called chromosomes in living creatures. And then you see how it's also positioned in the right place in the cell, as well as the right time of the cell. For instance, your eyes have all the information to build who you are, but you don't really want a bone popping out of your eye socket. Not going to happen because the bone information is switched off and only the eye information is expressed. So the cell in the eye has to have the eye information where it's accessible. The bone information can be buried deeply, but also we're very dynamic, so things change over time. So it's even got the code to change and to position the DNA in the right place in space and time. So there's some quite amazing programming in multiple dimensions. Now, I said also that DNA provides a way of copying the information to the next generation, but it doesn't do it by itself. It needs an enormous amount of help from lots of different machines. So I'm going to show you a very simplified program about how DNA is copied in living creatures.
Using computer animation based on molecular research, we are now able to see how DNA is actually copied in living cells. You are looking at an assembly line of amazing miniature biochemical machines that are pulling apart the DNA double helix and cranking out a copy of each strand. The DNA to be copied enters the production line from bottom left. The whirling blue molecular machine is called helicase. It spins the DNA as fast as a jet engine as it unwinds the double helix into 2 strands. One strand is copied continuously and can be seen spooling off to the right. Things are not so simple for the other strand because it must be copied backwards. It is drawn out repeatedly in loops and copied one section at a time. The end result is 2 new DNA molecules.
So this happens in even the simplest cell, but you see how complex the machinery is that's required to copy the DNA. Now, one problem for evolution, though, is that DNA has the instructions for its own copying machines, but you can't pass on those instructions unless you already have copying machines. Another thing is the copying machines must be incredibly accurate. You see, If you had only 100 letters to copy, only 1 in 100 of mistakes is allowed. If you had 1,000 letters, it's 1 in 1,000 accuracy. We have about 3 billion. So you imagine the accuracy that's needed to avoid passing on mistakes, because otherwise you get what's called error catastrophe. And this means you copy the instructions for the copying machines, you make a mistake. That means the next generation of copying machines is going to be less precise and therefore introduce even more mistakes when the next generation is copied. So the next machines are even worse, which do an even worse job of copying, which make an even worse job of the machine. So you see, it crashes to a halt really, really quickly. And also we can go back to Genesis 1, where it says that God created everything very good. And I think we can see from science that things had to start very good. They couldn't just start off being moderately good, because then that error catastrophe would break things down really quickly. So unless it started very good, as the Bible says, it couldn't start at all. So what we're seeing is what we see in nature as well as the Bible, that things started off very good, and now we've got things going downhill thanks to the fall. So things that started off good and they're going downhill. They didn't build up to very good. That's scientifically impossible, as I've just shown you. Now, another thing with DNA, think about it. I've told you it's a coily sort of molecule. They call it a double helix. It's like a spiral staircase with the letters being like the steps on a spiral staircase. Now, think about this hugely long coiled molecule. Now, it's only a few atoms thick, but in fact, the DNA of each of your cells, any one of your cells, the DNA laid end to end would be about 2 meters, about 6 feet long, you see. So imagine very thin coiled things 6 feet long, and how tangled up that could get. I mean, think about people who are a bit older and remember when you had landlines with the coils. I'm sure you remember them being tangled up. Now, this would be a real problem with DNA. But DNA, in fact, it needs a whole lot of help to solve this problem. I'll show you what actually happens here.
Let's consider what happens as DNA unwinds during replication. As DNA unwinds, it acts like this rope when we pull apart its 2 strands. As you pull the strands apart, twisting tension builds up in the rest of the coiled portion. It is actually adding 1 twist to the remaining rope for each twist pulled out of it. At some point, you can't separate the strands anymore. The remaining rope is too tightly twisted. If you relax your tension on the rope, it will twist around itself in a supercoil. It is releasing tension. If you want to keep pulling the rope apart, you have to release the tension periodically, and one way to do this is to cut the rope and splice it back together. This problem has been best characterized in small circular DNAs. There are 2 methods of dealing with this problem in DNA. One cuts only 1 strand of the DNA double helix, and the other cuts both strands. Let's look at the first. Topoisomerase I enzymes cut a single strand of the double helix, pass the other strand through the cut, and reseal the break, relaxing the overwound molecule, which now has 1 fewer twist. Topoisomerase II enzymes do the same thing but with both strands of the double helix. Topoisomerase II cuts both strands of a double-stranded DNA and passes another double strand through the break and then reseals the break. So if a molecule of DNA is supercoiled, topoisomerase II can remove the supercoiling, 2 twists at a time, to yield a relaxed circle.
Some pretty amazing machines. Now, again, all living things have to have this machine, and probably many different types of this machine. Now, think about what you need for this machine to work. It has to do 3 things. It has to cut, it has to splice through, and then it has to put things back together again. So if it doesn't do all 3, it's going to do more harm than good. So all 3 things have to be working together. Otherwise, this machine is going to be worse than having none at all. Another thing is that DNA actually has the instructions to build these enzymes, the topoisomerase enzymes, but it can't be decoded unless you have these enzymes already present. And it can't be copied unless you have these enzymes present. That's something I didn't show you in the previous video, that these things had to have been working while the DNA was being copied and gone through that whirring helicase. It had to have these things going to make sure it didn't get tangled up in the process. You had to have all these things working, otherwise living things couldn't work. And in fact, the antibiotic called the fluoroquinolone class of antibiotic, or levaquin and Cipro, these actually work by stopping the third step of putting things back together. That's how they work, how they kill the germs. You have these enzymes going through snipping the DNA to ribbons, but then it doesn't get put back again. So the bacterium dies. That's how this antibiotic works. Now, let's go back to DNA. Now, I did tell you that DNA has some pretty interesting design features that make it more stable, but it's still quite an unstable molecule. This was a surprise to people. Here is one scientist on this. There's a general belief that DNA is rock solid. Actually, DNA is highly reactive. On a good day, about 1 million bases of the DNA of a human cell are damaged. Now, why aren't we a mutated mess then? Well, this was something that was quite a puzzle to scientists. And the Nobel Prize for Chemistry in 2015 was awarded for discovering the problem and how living things solve it. These three share the Nobel Prize. And this comes from the Nobel Prize website itself. In the early 70s, scientists believed that DNA was an extremely stable molecule, but Thomas Lindahl demonstrated that DNA decays at a rate that ought to have made the development of life on Earth impossible. So he realized DNA, you can measure how fast it breaks down. Living things shouldn't survive. So he realized that there must be some repair machines that all living creatures must have to undo this damage to DNA that he found out did happen. And the other two scientists found other ways that we cells repair the damage to DNA that happens just in ordinary chemistry. In fact, one biochemist, James Shapiro, said that all cells from bacteria to man possess a truly astonishing array of repair systems. So without these repair systems, life couldn't work. But once again, DNA has the instructions to build its own repair machines. But you couldn't preserve those instructions unless you already had repair machines working. So again, living things had to have an enormous number of different machines. Otherwise, life couldn't start in the first place. And this has implications for the age of things too, because dinosaurs have had DNA discovered. I mean, Dr. Mary Schweitzer has written 2 papers where she's talked about DNA having been discovered with a pretty standard biochemical test. There's this probe molecule here called DAPI. And DAPI actually lodges in the double helix of a DNA and makes a fluorescent signal. I'll show you what sort of things it looks like. See the fluorescent signal here? It's saying here's DNA has been discovered. This is a standard thing. A biochemist sees this, he knows there's DNA. So this has been found in dinosaur bones. And the dinosaurs, the T-Rex is meant to be 68 million years old, and yet it has DNA. Now here are some figures about how fast DNA breaks down. Now, see, even if it was frozen at -5 Celsius or 23 Fahrenheit, it would actually break down completely in 6.8 million years. And that's to individual letters. There's no double helix anymore. It's just individual letters. Now, this is 1/10 of the presumed age of the dinosaur bone, which has DNA still with a double helix of probably about at least 12 units long. Otherwise, that test wouldn't work. And now, they also believe dinosaurs lived in warm climates. Now, as you can see, as you warm it up, the decay rate goes up enormously, exponentially, as you increase the temperature. So even a fairly mild temperature, like 25 Celsius, 77 Fahrenheit, it should all be gone in 22,000 years. So this is consistent with the view that dinosaur fossils we had were buried during Noah's flood about 4,500 years ago. That's why we still have some DNA, even though it's broken apart. We still see it with that test. But if it was millions of years, we shouldn't have any dinosaur DNA left. So this is a very good example of how this shows the dinosaurs cannot be as old as people claim they are. Now, let's look at a few other things here. I mentioned things like how DNA is the information storage system. So the mycoplasma, as I mentioned, has 600 kilobytes. Now we humans have about 3 gigabytes worth of information. So if evolution were true, it means that things like a mycoplasma must have evolved into humans, which have 5,000 times as much information as the mycoplasma. And if you like to think about what that means, it's about 1,000 Bible-sized books of information. Mind you, it's only 200 times the size of the IRS tax code. But the thing is, the information in books is written with ink on a page, but the information didn't come from the ink. This is not possible. And again, from our Evolution's Achilles heel DVD, the information doesn't come from the ink. It comes from the author who arranged the ink molecules into letters and words and sentences and paragraphs. And in the same way, there's nothing in the chemistry of a DNA to make it write the messages of life. Again, just as the information in the book doesn't come from the ink chemistry, the information in life doesn't come from a DNA chemistry. It's written with DNA letters, just as a book is written with ink letters, but the information is outside that. And information you could call a third fundamental quantity. It's not matter and it's not energy, and I can prove this very easily. I mean, think about this thought experiment. I want to save weight for the next time I travel on an airplane, so I should wipe my hard drive. That's silly, isn't it? Because wiping my hard drive doesn't make any difference to the weight of it. Even though my hard drive might be full of a terabyte or 2 of information, I wipe it to 0, it doesn't change the weight. So therefore, information isn't matter or energy. It's something outside of that and riding on it, but doesn't come from matter or energy. Now, think again about the book. And you see, a book requires a language too. You see, my books aren't going to be meaningful to you unless you understand the English language. You see, what if I gave you a gift? You're fairly happy if I give you a gift because it means something you get for free. Now, any German listeners I promise a gift to may not be so happy because gift in German means poison. This is the warning for the cyanide tablets used to wipe out 6 million Jews in the Nazi extermination camps. They had a warning, Giftgas, meaning poison gas. Okay, so gift in German means poison. And I had this confirmed when I was giving creation talks in New Zealand where my parents still live. And a German came up to me and said that I was right about the meaning of gift in German. And he said when he first came to New Zealand, he was appalled by our Christmas custom because we try to poison our families. So you see, we have to have the right language, otherwise we get the wrong message. Now, when it comes to DNA, though, now DNA actually has multiple languages on the same set of DNA. See, I mean, a book's quite amazing. You know there's at least a human intellect behind a book to write in English. I mean, no apes have anything like human language, okay? But DNA has multiple languages. So it's more like a book you can read in English and read it in German, you get another message. Read it backwards, you get still another message. You read every 10th letter, you still get another message. Everything makes sense. So multiple languages on DNA point to a superhuman intelligence far in advance of our own to put multiple languages on the same part of the DNA. And this is where the so-called junk DNA comes in. It's not junk at all. The concept of junk DNA belongs in the junk pile because we know that it's actually doing something. It's being read. And this is the other languages that people had not realized until fairly recently. Now, I'm going to show you one of the languages that gets read. That's the language to make the proteins. And I'll show you what happens. This is, again, another video that we have produced here.
This animation demonstrates how the digital information encoded within DNA is used to direct protein synthesis. This is a DNA double helix containing the digital code which directs the cell in all aspects of operation. And here we see a protein complex called an RNA polymerase traveling down the DNA strand. As it moves down the strand, it carefully unwinds the DNA, preparing it for transcription. Inside the polymerase, we see a single-stranded copy of the original instructions being assembled as individual bases are positioned and added to the growing strand. A stop code marks the end of the protein specification, at which point this copy, known as a messenger RNA transcript, exits the polymerase and heads towards a two-part chemical manufacturing machine called the ribosome. While the messenger RNA moves towards the ribosome, transfer RNA molecules attach to specific amino acids in preparation for assembly. As the messenger RNA transcript passes through the ribosome, the process of translation begins. Using the instructions encoded on the messenger RNA as a template, the transfer RNA molecules align specific sequences of bases to corresponding amino acids, creating a protein chain. As this chain exits the ribosome, it is met by chaperones which prevent premature folding, while escorting the protein to a barrel-shaped machine called a chaperonin. This machine helps fold the protein into the precise shape required to perform its function. Although it is unclear how the chaperonin achieves this, we do know that accurate folding is essential in order for the protein to accomplish its intended function. Once the protein is complete, it is released into the cytoplasm to do its job.
So yet more machines are needed to read the information in the DNA and make the proteins that build what we are. So again, we get this vicious circle, as I've mentioned with a few of the other machines, that DNA can't be read without its decoding machines, but the decoding machines can't be built without the instructions to build them on the DNA, which can't be read unless you have decoding machines to read them, but where the decoding machines come from without the instructions to build them. So you've got this, everything has to be working perfectly together right from the start. And the DNA decoding machines are mostly powered with ATP, which is made by the motors. Now, how do you get the motors? You need the instructions in the DNA read by decoding machines, which use ATP made by the motors. So what do you call a three-way chicken and egg problem? I mean, maybe egg, nymph, grasshopper, some insects have a three-stage metamorphosis, and maybe that's what you got there. But you see what I mean about how everything has to be working together, even to produce the simplest living creature. Now, this is actually interesting. See what I mean about the information being so essential to understand. And this is a death knell for evolution. I'll give you one evolutionist who admitted the problem. He asked, how did stupid atoms spontaneously write their own software? And he answers, nobody knows. You see, the origin of information is a crucial problem that evolutionists have to explain just by matter and time plus chance. Well, let's see if Richard Dawkins, the world's leading evolutionist, has a clue.
Professor Dawkins, can you give an example of a genetic mutation or an evolutionary process which can be seen to increase the information in the genome?
You see, even the world's leading evolutionists couldn't answer the question about where information could come from just matter and time and energy. But have I forgotten something here, like natural selection? Well, actually, no, I haven't. And I'll show you why. See, natural selection they can call differential reproduction. See, it's not so much survival of the fittest, it's reproduction of the fittest. See, natural selection says this thing is fitter than this thing, therefore this leaves more offspring. So what you have to have before you have natural selection, you have to have reproduction. And therefore, natural selection can't explain the origin of the first self-reproducing cell. And here's a very famous evolutionist from the 20th century, Dobzhansky. He's very clear about this. Natural selection is differential reproduction. In order to have natural selection, you have to have self-reproduction or self-replication and at least two distinct self-replicating units or entities. Pre-biological natural selection is a contradiction in terms. So we cannot use natural selection to explain the first reproducing cells. So this is a huge problem for evolution because Darwinian evolution can't even get off the ground. I mean, I'm not accepting Darwinian evolution anyway, but it can't even get started. And if it couldn't get started, it couldn't have occurred. Simple as that. And here is what I'm showing you has been an incredibly good witnessing tool. I'll show you, like the leading atheistic philosopher from last century was Antony Flew from Oxford University, where Dawkins comes from. Now, a few years before he died, he was still lucid, but he actually abandoned atheism and believed in a creator God. And one of the things that led him to this belief was the incredible complexity of living things. And he says here that Dawkins overlooks the fact that Darwin pointed out that his whole argument began with a being which already possessed reproductive powers. And this is the creature, the evolution of which a truly comprehensive theory of evolution must give some account. Darwin was well aware he'd not produced such an account. And here is a conclusion. Now, the findings of more than 50 years of DNA research have provided materials for a new and enormously powerful argument to design. Now, the only word of warning I'd have here is that design is not enough. It's incredibly powerful, but it's not enough because he never became a Christian, unfortunately. Okay, but at least it can lead people away from atheism, but I think we've got to go to the next step and actually show that Jesus Christ is the way, the truth, and the life, and how he proved his credentials by rising from the dead. And that's an important part, but it's after we show them there is truly a God, and we show that Jesus is creator, redeemer, savior. So thanks very much for listening to this, and I hope the questions have been all answered on the right side. Just a few things, just to say why we do what we do. Now, Dawkins is actually a very useful person to quote because he said Darwin made it possible to be an intellectually fulfilled atheist. You see, he and other atheists need evolution as a crutch for their faith. So what are we supposed to do about it? We're supposed to demolish arguments and every pretension that sets itself up against knowledge of God, and we take captive every thought to make it obedient to Christ. So we are unashamedly a Christian ministry, not an intelligent design ministry or just an evolution bashing ministry. Well, we want to point people to Jesus Christ as the creator and redeemer. And in fact, we're supposed to be prepared to make a defense or give an answer to anyone who asks you for a reason for the hope that is in you. And Jesus himself said the greatest commandment was loving the Lord your God with your heart, your soul, your strength, and your mind. There's nothing in the Bible about checking your brains in at the church door. We're supposed to engage our brains and nourish them on God's word, the Bible. And one way to do that is our Creation magazine, which I hope all of you have subscribed to, but also you can get a gift for people. But you see, here is why it's a great witnessing tool. This man came from a Christian home, but he went away from his faith. But then some faithful people actually witnessed to him, and part of it was giving him the Creation magazine, which showed evolution doesn't have a leg to stand on. The creation makes perfect scientific and logical sense. But if there's a creation, there must be a creator, and therefore he owns me. And how can I become right with him? And that's why every magazine presents the gospel. And here's a good example of what a great magazine for a family it is. Like this lady said that it encourages her own faith, but also she can teach her children the truth of creation, which the government schools aren't going to do, and to witness her unbelieving friends. And let's face it, it's not a question of should we witness to our children, but who is doing the witnessing. Make no mistake. People are witnessing to your kids, and most of it is very anti-Christian witnessing from all these glossy magazines and the media and Hollywood. So we should provide the right sort of witnessing. And here you can actually subscribe. Again, there's a shortcut here, creation.com/mag is the shortcut. And we can also get the digital subscription, which means you can give it to family and friends in different parts of the world. And what a great magazine is to pick up. And here's a classic example, an article in it, how do dating methods work? And this is not about how boys meet girls. This is about how old things are and how we can know. And when it comes to design, my own favorite topic, well, we have articles on design all the time. And one of the most interesting topics is how humans are learning to copy from the designs in nature. What we see in nature has given people ideas they never would have thought of otherwise. And people think that these engineers are so brilliant, but they're only making the copies. What about the one who made the originals? And some other books you might like. Here, there's a book here. I mentioned how design is not enough. Well, here's the next step: Christianity for Skeptics. Why do we believe Jesus is the Christianity the true religion? By the Bible's the Word of God. How Jesus rose from the dead. How do we answer other religions like atheism, Islam, Hinduism? And as mentioned before, some of the clips I had are from this video here, which has a free study guide going with it. And remember, creation.com/store, you can find all sorts of things there. And also, here's an example of a book about how humans are copying from God's designs here. This is Dr. Stuart Burgess, who's won awards for the way he's copied nature, but he actually gives credit to the creator, the original. And also, just to mention some things here, here are some ways you can keep track of us online, especially while we're all locked down with the pandemic. All these different things, you can find out more at creation.com/creation-talk. It's got a whole lot of our podcasts and webinars and Creation Magazine Live, and you can find it on whatever your favorite platform is. So thank you for listening, and God bless.